Hello, and welcome to my talk, Druid SQL for Queries, from an overview to tips and tricks. Thank you for joining. My name is Ben Krug. I'm a senior technical support engineer at Imply. You are probably aware that Imply is a company that employs many of the creators and contributors to Druid. We offer our own version of Druid, as well as contribute heavily to open source Druid and provide community support for open source Druid, as well as obviously support for our own product. I would like to take a few seconds to give you an idea who I am by sharing a short video.
I lied. I don't dream about noodles, Dad.
Substitute SQL for Kung Fu. I have a long background in databases as a developer, DBA, sysadmin. I started with spreadsheets actually and macros, and then worked with MUMPS, a hierarchical database, and then went to SQL and worked with pretty much all the major companies that had products based around SQL. Then did some more hierarchical database work and graph database work. Did some work for Cassandra, who moved to SQL while I was working with it. And that was a smart move for them because SQL is a great product and they were going towards more SQL kind of approach. And then I came to Druid, and at the time, a lot of the queries were what are called native Druid queries, JSON queries, but the movement has been towards SQL, which makes me very happy because my first love has always been SQL. So this talk is a bit of an introduction to Druid SQL and some of the things that were new to me, maybe new to you if you're starting out, what it covers and doesn't cover, and a few tips and tricks. Sorry for flipping around. The first part of the talk is a bit of an overview of Druid SQL. Because of time limitations, we won't cover everything, obviously, but we'll give an overview and then go on to some tips and tricks that I have come across. To begin with, what is it? Obviously, it's a means to query a Druid database. We strive to comply with ANSI SQL. It's not yet a complete implementation of ANSI SQL. Over time, we support more and more. At the same time, it's not a subset. It does contain Druid-specific functions that are not in ANSI SQL and are tailored towards the specific needs and desires of Druid's nature and the users of Druid. So the first thing to kind of talk about is how it works. And as I said, originally, Druid was queried with its own query language, but so as not to reinvent the wheel, maybe, we use a translation layer called Apache Calcite, which is a general way to translate other kinds of queries, SQL queries into other kinds of queries for an underlying database. I have a link. It's not for the faint of heart. It's very abstract, but it's very useful to us. And it translates your SQL query into a native JSON query. And those are the OG Druid queries. The problems with them, or the cons, are that they're difficult to read and write, easy to make mistakes. It's JSON, steep learning curve. And in some cases, it's less flexible than SQL because, for example, a single SQL query may translate to multiple Druid queries. So with one SQL query, we can do something that you could not do with a single native Druid query. I guess you would have to do some extra work in your app layer if you have a layer that you're putting between yourself and programming. But with SQL, you can just do it with the SQL query. One nice thing, if you're really getting into it, is that about native queries is they're a little more imperative than declarative. So they tell you a little more about how the query is actually being executed against the database. A strength of SQL is that it's declarative. You just tell it what data you want, it figures out how to get it for you. But anyone who really gets into them wants to get some insight into how it's being run under the hood, and looking at the native query can help you do that, which we'll talk about a little more later in the talk. What will we talk about overall? We'll talk about what's supported in Druid SQL, or some highlights, again, limited time here, and also what's not yet supported. One thing we won't talk about is the new multi-stage query engine. This allows you to do insert statements, update statements, create table statements. So it's really cool, but it's a big topic in itself, and there is another talk about that. If we talked about that, it would crowd out a lot of the other stuff that I'd like to talk about. So I leave that to the other talk for the most part. There'll be a few passing mentions. Otherwise, we will talk about a lot of the things that are supported or not supported that you're going to run into just when you're trying to query the database, get data out of it. Some highlights, very brief, obviously, are some things that are supported are common table expressions, some joins and unions with caveats and restrictions that we'll talk about. Some things that are, well, one thing that's not yet supported is window functions. And we'll talk about a way to get around a little bit of that. And I should say that, as a warning, I'm not a huge fan of slides. So a lot of this talk will be me talking, and the slides might be kind of sparse. So it might be more listening than reading, but I hope you'll bear with me. For the first item, common table expressions, if you're not familiar with them, it's a way to basically have a named subquery. For example, with my table or temp table, tell it the column names and tell it the query, give it a name, and then you can reference it in your main query. What's the use of this? Well, a big use is that it can really simplify the readability and the writability of your queries. I've seen queries with multiple CTEs. It's easy to do just commas after each one, and really helps your queries to be readable and helps to build them. They are under the hood executed as subqueries, and they are helpful to the designer and the reader of Druid SQL. Another thing that we do have, which if you look at old references, you may think that we don't, is joins. You can join data sources, but it's limited. You can do inner joins and left outer joins, and you can only join on equality conditions. You can't join on this field is less than that field or like that field or anything like that. They can be expressions, but they have to be this equals that. Currently uses a broadcast hash join algorithm. What does that mean? It means that the right-hand side of the join gets materialized before the left-hand side goes to work. So the right-hand side needs to fit in your heap, so you want to keep it as small as possible. I say currently because if or when some of the multi-stage query engine code gets incorporated into more general areas of SQL, this may not be a limitation in the future, but it is right now. Docs will tell you that whenever possible for best performance, it's good to avoid them. This is true, but sometimes you may not be able to join them. To avoid them. In some cases, you can do it by kind of pre-joining in your ingestion, just load all the data into one data source. But in some cases, it just makes more sense to use a join for overall manageability. And the performance is workable. So it's used commonly, multi-joins even I've seen used. And I've included a link to the docs about joins. Another kind of a join sort of is using a lookup table. These are key value tables, and it's a join, but the syntax is different from a join. The nice thing about these is that they're preloaded in the heap, so they're fast. On the other hand, they should be used with discretion, where you keep the number of rows, say, under 1,000 if possible, and don't have huge numbers of them. The downside is they take up the heap space like a join, and they're in there all the time. So again, use them with discretion and with testing. You may hear about something called index tables. They're like lookup tables, but have multiple columns. They are not supported if you use streaming ingestion, and most people who use Druid would like to use streaming ingestion. At this point, they may not be helpful for you. The good news is that, again, with multi-stage query engine, if that gets incorporated into the SQL code more generally, this may not be a problem in the future. You could do joins between big tables. There'd be a performance impact, but it wouldn't use the broadcast hash approach anymore, and so it would be possible. We do also support unions, but with limitations. And here, for some reason, for me and for other people, it takes some time to understand these limitations, even though they're really pretty simple and the docs are pretty clear and there's not a lot to it, but I don't know why. It just takes a few readings to kind of get it into my head. But the limitations depend on where you use it in the query. You can have it top level, which means your query is just give me this union, give me that. And then your queries can be anything that Druid SQL supports, and it will just execute one and then execute the other and give you the results. The con to this, or the downside, is that you can't do aggregations on the results, because it's just going to do one query and then the other and give you one and then the other. So you can't do aggregations on the union data. Now, if you do table level, which means your join is, your union is inside of a subquery on the from clause, then you can do aggregations on the results. But the limitation here is that the things inside your union can only be simple table selects, meaning select these columns from this table. Can't have any functions, can't have any where clauses. You could have some outside of the union, but not inside the union. So these are limitations to be aware of. May have to play with it a bit. For some reason, like I said, it can be hard to kind of get it into the person's head, but it's not as complicated as it seems. Some other features that are kind of unique to Druid include multi-value dimensions. JSON is not unique to Druid, but multi-value dimensions are a way to store an array in a field, basically. So like a way to make a wide row. For example, you might have tags that you store in an array. If you do want to use them, I recommend looking at the docs on them. They behave in some ways in aggregations that might be surprising to you. They were to me. If you group by them or sum on them, they can have some unexpected results. Also, if you have, for example, a tag that's repeated several times in one row, it'll get counted that many times. So that can be handled at ingestion time. You can deduplicate by setting the options for a multi-value dimension to use sorted set instead of sorted array, which is default. Sets don't have duplicates, so it will deduplicate it for you, but it can't be handled at query time. So something to be aware of. Another way to do maybe a similar thing is to use JSON, which is new functionality relatively in Druid SQL. And you can store JSON in a field and extract the elements using functions that are specific to JSON. So these are two things to kind of be aware of and look into if you're starting out with Druid SQL or using it and have a need to store multiple values for some row. A more general thing to be aware of is the query context. This is a way to set some parameters for your query, like timeouts and things like that. The way that you set them depends on how you're submitting your queries. In the console, there's an option to edit your query context near the run button. And you can edit it. It's a JSON item. There are some options in the console that you can set with radio buttons that if you then look at the context, you'll see they're just context settings that are getting set in the context. If you use the API, there's a JSON item that you can pass in the body of the query that sets the context. JDBC, you can pass it as options. So I've included a link for query context in the docs, and it's definitely something to be aware of if you're using Druid SQL. One thing that touches on another important topic, especially for people who are new to Druid SQL, is that Druid SQL queries and Druid queries in general are designed to be fast. By default, some of your results will be approximate. Say you're looking at clicks, for example, and you want to know the pages that get the most, the top 10 most visited. You may not need the exact value of clicks. You might just want an approximate value. It might be good enough if it's a good approximation. Sometimes approximations might not be good enough for you. So you can set this using those radio buttons in the console, but you can also set these in the query context. And the more general one is use approximate top n. In particular, if you're doing count distincts, there's a use approximate count distinct option. You can set these to false in the query context to get exact results. But know that your queries will take more resources and be slower. So test it out, use with caution. And I've included a link to the doc page or to the KB article about some of these options. Something that is surprising to sometimes to users of Druid SQL. Something to be aware of and a good thing to know how to get around it if you need to get around it. And speaking of approximate results, sometimes you really do want approximations. Again, say you're looking at clicks, or maybe you're looking at users who visited a site or a page, and you don't need to know every single user, but you want to have an idea of the number of users. There's a community extension called Data Sketches, which allows you to store statistical information about unique values. Could be tags, could be users, something like that. I mean, clicks or users. And they can be very fast to give you approximations. What they can also do is say you're looking at unique users who visited a page. Maybe you want to see the users who visited this page and also visited another page. If you just store the counts, you can't do that. If you store sketches, now you can do operations like that. How many did this and that? How many did this or that? And a lot more. So I've included some links about sketches and about the special SQL functions that you use if you're using sketches. And also a link to a blog page by Helmar Becker, which is very nice if you're looking into sketches for the first time, and it kind of walks you through it, what they are, how they work, how to set them up. So this is kind of a super quick overview of some highlights of Druid SQL and some of the functionality, some of the limitations, some things to be aware of, how it works, some good doc pages to know, to bookmark. I have them bookmarked, are an overview page and also one that lists all the functions in one place alphabetically. So when you get more familiar with it, you might just be looking for particular functions like MVD functions that you know start with MV underscore, and you don't want to have to click through to the right subsection to find them. Everything's here in alphabetical order, and you can just go in there and look for it. But I'd also like to give some tips and tricks as promised. So the first one is kind of a throwaway. It's super easy. And that is union. There's limitations, as I mentioned. And sometimes, if you can, the best way to get around them is to do the union in an app. If you're programming in an app and you can do that, just run the query separately and then combine things in the app. This might not always be open to you, but if it is, it's something to consider, and you might get more flexibility and better performance doing it that way. Another is for group by queries. They can take a lot of resources and sometimes be slow. So you want to try to tune them to do as little aggregation as possible, like maybe not include unneeded fields in there. But sometimes, you need what you need. So by default, they'll do everything in memory, and you may quickly get an error suggesting that you allow spill to disk by setting max on disk storage. This is a setting that says it's default is 0, which means don't spill to disk, do everything in memory. If you set it, it says spill to disk up to this amount. It's set in bytes. So know that I've seen cases where people set it orders of magnitude lower than they think they are because they don't realize that it's set in bytes. And sometimes I've seen where 10 meg or 100 meg is enough. Sometimes I have to go up really big to a gigabyte or 10 gigabytes. But know that this is per query. So have enough disk space. Know, how many concurrent group bys you might be having, how much disk space that might take up. If you need to point to a different directory than the default directory for this spill, I believe by default, it will go to var temp. Not 100% sure, but I think so. You can change this using tempter either in the JVM properties or as a Druid setting under Druid processing tempter. Precedence is given to Druid processing tempter. So if it's set in both places, that's one it'll use. If you do it, just be aware of the resource and performance implications and test things and use with caution. We have some things that I think are good to know if you're using Druid SQL. First is the filter clause function, whatever you want to call it. It's a where clause that applies to a single aggregation, a single thing in your query. So in this example, which I'll talk a little bit more about, but as you can see, like we have a latest, and then it says filter, where, blah, blah. So it could be a sum, it could be other things, but I only want to consider the values where something is true when I'm taking my sum or my average or whatever I'm taking. And it can be different for different columns. So, it has great flexibility and is super helpful. You don't need to have these wheres down below in your main where clause. Maybe you only want them in a particular place in the query. This particular example, they were using the latest function to get something. And if we just had the latest in the having clause later on, it wasn't working as they expected, because we'd get the latest value and it would just be the latest of all the values. And then later we take a having where some condition is true, but we're still getting the latest without that condition. So we could put it into each field and say, I only want to take the latest where this is true. And then in the end, I could say, I only want the results where this is true. And they're doing two different things. So it's great to be able to do it in both places or either place as needed. And definitely something to like play out and try with. It's a powerful functionality that can be very helpful in writing your queries, simplifying them, getting better functionality. Another thing that I mentioned earlier is that we don't have window functions, but for moving averages, there's a community extension that you can load, and you can do moving averages and some other window functions. So if you're looking for moving averages, you're covered, and this is the place to look. You can see what else is supported. Also, I've seen people ask for window functions where they just wanted to calculate change of some fields over a given period. You can do this now using a function called time shift and CTEs. Basically, you set up a query that of the table, like the present view, another one that's time shifted by a period, do a join and subtract. So it's kind of a trick for calculating deltas. And I've included an example query in case anyone is looking for this particular thing to refer back to and kind of work from. So these are a couple things that might help you out if those are particular things that you need in the area of window functions. One miscellaneous item is that it has hit a number of people in my experiences, especially if you have generated queries. If you have very long in lists, like 1,000 values, it can be super slow. And the problem is not actually running the query. The problem is planning the query, translating from SQL to native JSON. The calcite layer will try a bunch of different combinations to try to see which one it thinks is optimal. I've seen this take like 60 seconds, just going through all these different permutations. You can skip this currently by doing kind of a hacky workaround of using MV overlap, one of the multi-value dimension functions. And you say MV overlap, the field you're looking at, this array, it means it's the same as saying this field value is in these values. The reason this helps is that calcite just says, I don't know anything about MV overlap. I hand it over to Druid, and Druid says, cool, and runs with it. And calcite doesn't sit there trying 1,000 different permutations to see what it thinks is going to be best. So for now, that's a workaround, and it's not guaranteed to always work, but it may be very helpful for now. And hopefully the performance for long in lists will be improved in the future. Another tip is for designing your queries. I recommend using the Druid console. It's a really nice place to work in and to build your queries. Shows you the schema, shows you a lot of things. There are options under the engine button. You can disable the approximations and limits and things for testing. You can look at the context and edit it by clicking on the edit context option, also near the run button. So it's a really good tool to work for. And what it can also do is make it easy to look at the underlying JSON if you're really getting into the nitty gritty of things. There's a explain plan for option that you could do in the SQL, or in the console, there's an option under the three dots next to run explain SQL query. And it can be helpful to see how the query is being planned. Once you get to know the different query types, you'll get an idea of what's faster or not faster. Maybe you'll try different things in the SQL query and see how they get planned. And maybe you'll come up with a better SQL query that performs better. It takes time and takes a while to get to know the different query types, but if you're really getting into it, it can be worth it to learn some of these details and to see how it works. Again, I just want to share these doc pages that I have bookmarked and refer to a lot. They're helpful when you're writing queries. SQL syntax, the functions, the options. When you get more familiar with functions, it's good to have just a list of them all alphabetically to find the one you're looking for. I recommend keeping it bookmarked and referring to it a lot. And I hope that quick overview has some helpful elements for people. If you have more questions, I should say, please don't hesitate to ask them on the Druid forum, in the community Apache Slack. If you're a customer of Imply, open support tickets. We're very happy to help work on queries and Druid SQL queries, especially me. I'm happy to. Thank you for joining. Hope it was helpful, and have a good day.